Welcome to the Urban Air Quality Analytics platform. In this video, I will explain the core architecture and key features of my full stack analytics project built with FastAPI, Postgres, and 𝗫𝗺𝗫𝗁. Some key features, as I mentioned, we are building the backend with FastAPI and Postgres, then the dashboard using 𝗫𝗺𝗫𝗁. Now the architecture of our project is like first the CSV is ingested into PostgreSDB, then using that the CRUD operations and all backend queries are handled, then we finally create dashboard. So now this is the folder structure of our project. First we have a backend folder, then a dashboard folder. Now let's see the backend folder. We don't need it by cache. So now this file models.py defines the database schema using SQL Alchemy ORM. The air quality model represents one city's air quality per day and is the foundation for all analytics. And the UUID is the unique ID for each rows. Now moving to the database.py, this file manages database configuration and connections securely. We use database URL safely encoded, and also we load all the credentials from the .env file. Now this is the file for ingestion, the script that we use for ingesting CSV file into the database as a table. So the cleaning and all the steps are done here. This is the data we are going to insert. So let's see how it will work. So first we will run it, then we will see. So now we are not in that directory where the file is, so we will move back to backend folder, and from there we will run this file. So the message shows successfully inserted all 100 records. So now we will verify it by writing the query and checking for the table. For that we will select all from the table name that we mentioned, table air quality records. Then we will run. So here you go, all the data is here in the table with all columns and rows all in our database. Now we will go to the core part of our project, which is main.py file, where all the CRUD operations are implemented, the core backend, and also there is the database dependency using the getDB. Then the bidynamic schemas separate internal ORM models from API responses, and all the CRUD points like the create, read all, and all. Then we have one key endpoint like the analytics endpoint, which is beyond CRUD points, like it is basically the logic from the dashboard itself. And then, for example, the average AQI by city and AQI trend over time. Now coming on to the JWT authentication, which secures write operations like create, update, and delete. And also here we have taken only the dummy user, and which can be easily extendable to real user on later stage. So this was all about JWT authentication. Our backend is complete. Now I will run the server and will show you all the CRUD points and its functioning. So now we will open the browser and will go to localhost 8000/docs. So here are all the CRUD points that we mentioned in the main.py. Here we have the get CRUD point, which will show you all the cities, all the records in the data. response is 200, so that means it's okay. Now we have another get point for the analytics purpose, as I mentioned in the main.py, which is from the dashboard itself, which will show some specific visualization as well in the dashboard. And then we have the create and delete method, but we cannot access it until we get authorized. So first we have to do the authorization step. Here I will mention the username and password, then we'll click on user, and then we can use the put endpoint as well. I'll put some record ID from the record itself. Let's take this one for Bangalore. Let's say 9, and then if you execute it, and you will get the message response okay, and then if you will see, it will be there in the data. Now we'll delete it. So it says record deleted successfully. Now let's move on to our final stage, which is dashboard, which is in the dashboard folder app.py. So here we have done all the visualizations, KPI cards and all. We have categorized AQI on the basis of their values. And then the layout, the manual refresh button is there. And then the KPI cards, as I mentioned. Then the drop down for various cities. And then the KPI callback, which will change according to the drop down and for specific cities. And these are all the visualizations that we have used. The correlation is also there, and the average good and bad days. Now we will run it. First we have to move back to the directory where it is, the dashboard folder. Then we will run python app.py, and then the server will start localhost 8050, and here you go. All the dashboard, all the visuals are here, the refresh button, the drop down menu, and the KPI cards, which will change according to all the cities. So that's all. Thank you for watching my explainer video for this project. Hope you like it.